So starting with the pop quiz, which was related to the thermal physics. Explain in terms of momentum of the particle how the gas exert pressure. As I mentioned, this type of a question is very common in which you have to explain the pressure in terms of momentum. So what you'll mention the gas molecules are moving randomly and they hit the wall and bounce back and they change the momentum exert force on a unit area. So how to write this answer? First thing, the gas molecules are moving randomly. If the molecules are moving randomly, they change the direction and momentum. When the gas molecules are moving randomly, they will change the direction as well as the momentum. And whenever they change the momentum, the particle to change the momentum, they will exert force on unit area. And when they exert force on unit area, it will create a pressure. So these are the points. So this is a fixed answer, and it's a very common question you will find in thermal physics. They ask that explain the pressure in terms of momentum. So it's like particles moving randomly, collide with the wall of a container, changes a direction, exert force on a unit area, and that create a pressure. The next, the temperature of a sample of a gas is increased at a constant volume. Means the volume is not changing. The size of the container is not changing, but we increase the temperature. State and explain any change in pressure. So if we are increasing a temperature, the particles will move faster. As the particles will move faster, like they will have a greater kinetic energy or there will be a greater change in momentum because when they're moving faster, the change in, sorry, when the particles are moving faster, so when the temperature, we increase the temperature, the speed or the kinetic energy will increase. And when the speed or the kinetic energy increase, there will be a greater change in momentum. And because of greater change in momentum, the particle exert greater force or on a unit area. And as a result, it will increase the pressure. So it will increase the pressure as the particles are moving. Then another sample of a gas. One more point, what I observed, some of the students are not at all writing a formula. So this is not the way to solve question in physics. You have to write a formula. Because as I mentioned, 1 mark is for either writing a formula or showing a substitution of the values in a formula. So another sample of a gas is C in a sealed container, which is having a volume 170. So that is V1. Exert a pressure of 9 exponent 4 Pascal, that is P1. The volume of a container decreased by 70. So if it is originally 170 and it is decreased by 70, so what will be the final volume? The final volume will be, because like originally it was 170 and it has reduced by 70. So what is the final volume? The V2 will be 100. Why 100? Because 170 minus 70, it's not like they say the final volume. If the question was like final volume of a container 70, then V2 will be 70. But the question is volume of a container decreased by 70. So if 170 was original and decreased by 70, it means the final volume will be 100. And for gas law, we'll use a formula P1 V1 equals P2 V2. So first pressure, this is 9 exponent 4. The first volume is 170. The second pressure we don't know, and the second volume is 100. This 100 is divided, other side it will be multiplied. So 9 into 10 power 4 times 170 divided by 100, that will give us the final pressure of the container, which is about 1.5 15 exponent 4. Okay. Yeah. So it is equal to 15 exponent 4. And the unit will be Pascal. So how the marks are distributed here? 1 mark is for the final answer. 1 mark is for this formula. And 1 mark is for showing that the final volume is 100. So it is important that you write a formula whenever you're solving a question. In question 2, figure 5.1 shows an aluminium block after leaving a furnace in a factory. Aluminium block of aluminium is there. There's a furnace, solid metal rollers are there, a factory worker. The mass of the block is 1,200 kilogram and it is heated in a furnace from 20 to 380. The block does not melt. Specific heat capacity is given. We need the energy. So the formula, look, we have the formula, the energy in when we have the specific heat capacity, specific heat into mass into temperature change. So specific heat capacity is 960, like this is C. So this will be 960. The mass of a block is 1,200. So 1,200. One thing you have to keep in mind, like if the unit of a specific heat is joule per kilogram, then the mass will be in kilogram. If the unit of the specific heat is joule per gram, then the mass should be like joule per gram degree centigrade, then the mass must be in gram. And the temperature change from 20 to 380. So the change in temperature, it will be high 380 minus 20, which is 360. So when we multiply, it is 414 or 415 exponent 6. So 415 into 10 to the power 6. And the unit of energy, that is joules. And how the marks are distributed for this one? Like 1 mark is for writing a formula. 1 mark is for the temperature change. You take as 360 or 380 minus 20. And 1 mark is for the final answer. The next is in figure 5.1, shows a factory worker stand 3 meters from a block. State and explain the main process from which the thermal energy is transferred to the worker, and it's of 3 mark. So how the thermal energy, because it's a hot object and a hot object release infrared radiation or IR radiation. So the IR radiation or infrared radiation will also reach this worker. And how these radiation can reach, because these infrared radiation does not require a medium, they can travel through vacuum. You just have to explain here the part. So state and explain main process by which thermal energy is transferred. So the main process by thermal energy is transferred is by infrared radiation. Or you can also say thermal radiation. And because these thermal radiation can travel through vacuum, does not require a medium. If any solid, liquid, or a gas, it does not require any medium. Without a medium, it can travel. And so infrared radiation, 1 mark is for mentioning the thermal radiation. 1 mark is for mentioning from block to the person. And these radiations are absorbed by the person, and because these radiation can travel without medium, that's why a person will feel the heat. Is it clear, the last part B of question 2?